if we are recording. Okay, we are recording. So we started to do a Python script that will encrypt a password for us. So let me come back to that. So the theory is in the file that I sent you. So remember that the first part, we have to compute in the initialization part, we have to compute part 01, part 02, and part 03. We already did that. And we were going toward the second part, which is a loop of 1000 times. So let's come back to the loop of 1000 times. It stopped there. So we will loop 1000 times. And each time that we will loop, the variable I will represent the index. And I will vary from 0 to 999. And according to the value of I, we will concatenate some value. So for example, if I is even, we concatenate intermediate to have the new value of intermediate. If I is odd, we concatenate password. If I is not divisible by 3, we concatenate salt. If I is not divisible by 7, we concatenate password. If I is even, we concatenate password. If I is odd, we concatenate intermediate. So for example, let's do it for 8. And understand what will happen for 8. So when I come at iteration where I is 8, so I will ask, is 8 an even number? Yes, it's an even number. So I need to concatenate intermediate. Then I will check the second condition. Is 8 an odd number? No. So I don't concatenate password. Then I will ask, is 8 is not divisible by 3? It is true. So I need, after intermediate, I need to concatenate salt, as you can see. Then I go with the condition number 4. If 8 is not divisible by 7, this is also true, no? So I need to concatenate, after salt, I need to concatenate password. Then I go to condition number 5. If 8 is even, true, it's even, so I need to concatenate after password, I need to concatenate password again. And then I will ask if 8 is odd, it's not the case, so I don't concatenate anything else. So the new version of intermediate will be the concatenation of the previous version of intermediate, salt, password, password. And I need to compute the MD5 of this concatenation. Okay, so it's say here make 1000 iteration on calculating the new MD5 hash based on the previous MD5 hash, concatenated with alternating the password and salt. So we need to compute the new MD5 hash. Okay, so I did this reminder, so we should be able to start again where we left last time. So let me go back and edit the file again. So that was this file that we were doing. Okay, so let me go to the end. And we make a we see that everything is working well with it again. So let me execute that. The password is Eric. On the exercise that we are doing, the salt is, here is the salt. This is the value of the salt. So let me copy it and let me put it as another parameter here. So up to now, we compute the initial value of intermediate. And as you can see, we can compare it with the one that they give us here, and it's the same one, as you can see. No? Let me show you again. So these two values are the same. So we have the initial value of intermediate. So we can do our loop. So let's write our loop. So help me with that. What should we do? We are in Python, no? So we want to do a loop for a variable I that starts in 0 and go up to 999 inclusive. So I should write what? Correct. So I can just write, 0, 1000. But I can also write 1000. If I don't stay the starting point, it will start in 0 and it will end in 1000 excluded. If 1000 is excluded, we will go up to 999. So before we do it, let's verify that we don't have problem with what we are doing. So let's just show a new value of intermediate. So let me write for now, new intermediate will be what? At the beginning. I want to show 12 message. I want to show intermediate password when we are in 0. Then password, salt, password, intermediate. So let's work at the beginning with strings. And then we will replace the string with a series of bytes. So here is what we have to do. So if we are going to work with strings, the value of intermediate at the beginning is empty. Entonces, I should write the first condition, condition 1. So if I is even, how can I write if I is even? If I modulus 2 is equal to 0, okay? If the modulus of I, when we divide it by 2, is equal to 0, I know that the number is even. So if it is even, what should I do? I'm going to compute a new value of new intermediate, no? On this new value, I need to concatenate intermediate. So let's just say we are going to concatenate intermediate. So as you can see here, I'm working with string to just explain you at the beginning. And I'm done with the first condition. Now let's write the second condition. If I, can I check that I is odd? Yeah, if modulus I modulus 2, when I divide I by 2, I get a remaining of 1, it will be odd. So if I is odd, what should I concatenate? I need to concatenate password. So let me put here password. By the way, let's put space. So it's not it will not be glued to the previous one. Yeah, the first one might have a space. Okay, we don't worry if the first one have a space at the beginning, it's not a problem. Let's write the third condition. If I is not divisible by 3, we need to concatenate salt. So what should I write here? Exactly, if I modulus 3 is not 0. So it's not a multiple of 3, it's not divisible by 3. So it will be 1 or 2. Another way to write it will be like that. In this case, we have to concatenate salt. So let's just put here that we are going to concatenate salt. Then, what else? With the fourth condition, they say if it's not divisible by 7, we need to concatenate password. So it's very similar to the previous one. I just copy it. I'm going to replace the 3 by a 7. If it's not divisible by 7, I need to concatenate password. So then we have, if it is even, we need to concatenate password. Let me copy this two line and just replace. Even will be when I divide by 2, I get a 0. So if it's even, I need to concatenate password. On the last condition, and if it is odd, I need to concatenate intermediate. Let me copy these two lines and say if it is odd, which means when I divide by 2, the remainder will be 1. I need to concatenate intermediate. So let's put here intermediate. So we will have just a small default. Maybe we will fix it after. But let's run this and let's show the value of intermediate. So let's put iteration. We are going to put here a number. I want to put a number of a 3 decimal. And then we are going to put the value of new intermediate. So dot format. So the first one is I. I will correspond with this placeholder. And the second one will be new intermediate. New intermediate. And new intermediate will correspond with this placeholder. So let's run that to see what happens. So it's going to show a bunch of results. So let me type at the end pipeless. Okay, I forgot to start the string, the double quote here. I did close it, but I didn't start it. Okay, let's do it again. Okay, so what we have in iteration 0, we have intermediate password, which is correct. Then we have password, solve password, intermediate. Let me put it like that so we see it better. Password, solve password, intermediate for iteration 1. We have a space here. This is the default that I was telling you. We might have a problem from time to time. We can fix it after. Then we will have for iteration 2, we'll have intermediate, solved, password, password, intermediate, solved, password, password. Then we will have password, password, intermediate for iteration 3, password, password, intermediate. So it looks like we go well. Okay, so if we want to solve this issue of sometime we have a space at the beginning, what will be your recommendation? What can we do here if I want to remove this space at the beginning? Put this space at the end? But do you know why the space came? If I don't start with intermediate, here I have password. Oh, oh yeah, I understand what you mean. So you mean I put the space here? Yeah, you are right, we can do that. So here I can do this. We will have a password at the end, but a password at the end, we will not see it because we don't write anything additional. So we can do that. You are right. So let me do it. And rerun. And it should look perfect because we will not see from time. We have a password at the end. We have a white space in all cases, but we don't see. So it just look perfect. We can just go up to the last iteration. For example, iteration 999 will be password, password, intermediate. And they tell us iteration 999 have to be password, password, intermediate. So we are doing well. Okay, so now that we see that we are doing things right, let's implement them, not with string, but with series of bytes. So in intermediate, in this moment, we have a series of bytes, and we need to apply this to our series of bytes. And remember that when we have the new value of intermediate, we need at the end to compute the MD5. So tell me, what should we do here? So we will start with an empty series of bytes. This is an empty series of bytes, have nothing. Then what should we do here? We need to concatenate intermediate. So intermediate is already a series of bytes. So we concatenate intermediate. Here we need to concatenate password. What is password part for me? Is password a series of bytes or is password a string that contains ASCII character? In my exercise up to now, what is password? How do I get password? It's a string because I read that and it's a string and I put it in password. So it's a string. So I need to convert this string into a series of bytes. So how do we do that? We have a constructor that is called bytes. So we can just write bytes. I'm going to convert password, and inside password, I have a string that it's an ASCII string. So this is the way that I can do it. Okay, now I need to concatenate salt. So salt is also a string. So I'm going to do the same thing here to say, please convert it as a series of bytes. And salt is a string of character. And inside we have ASCII. Then we need to concatenate password. The same thing, password is a string, so I need to convert it. So I'm going to put byte of password, and this string is in ASCII. And we need to concatenate password also. So the same thing, I need to convert it to a series of bytes before I can use it. So we should have the right value. Oh, we still have to concatenate intermediate. Intermediate is already a string of bytes, so I don't need to convert it. Okay, we have all the 6 possible cases. So what is missing before we show the value? What should we do? We need to compute the MD5 of the new intermediate, and that will be our new intermediate. So let's compute in intermediate the MD5 of new intermediate. So let me put in intermediate the MD5. So when we compute the MD5, remember that we have include a package which is called #lib. It have a method that is called MD5. You give it a series of bytes. I'm going to give it new intermediate. And to have the MD5, because this will be an object. If I want the MD5, I need to call the method that is called digest. Okay, so that will compute the MD5. And here, if I want to show, what I'm going to show is intermediate, because I just compute the new value of intermediate. If I want to see it nicely, I need to convert it to a string of hexadecimal. So let's run that now with this modification. We have a problem here. Let's see. Password is not defined. Oh, it's passwd that we call it in the program. So let me go back and look at the beginning here. We take argument number sub1 and we put it in a variable that is called passwd. So here is not password, but it's passwd. So let me put wd here, wd here, wd here, and we should be good to go. So let's see. That's the initial value of intermediate. As you can see it here. Let's see if I can put both. So I will do that. Okay, now we have both. So the initial value of intermediate we have computed last time. So look at iteration 0. We should have A589. We have A589 and it ends with 5243. It ends with 5243. Look at iteration 1. It's also correct. 6E00, 6E00, and it ends with 67E3, and it ends with 67E3. So we might just verify the last iteration to be sure that everything is okay. So let's go up to the end. We will have iteration 999. That should be 0056, 0056 at the beginning, and it ends with 627E, 627E. So bingo, I did the second part, which is the loop of 1000 times what we have seen. So I'm good to go with the third part. So we can have the encrypted field. Remember that the password is 3 parts. The magic number, then we have the salt, and then we have the encrypted field. And everything is separated by a $. So we'll have $1, then we have the magic, we have the salt, then we have a $, then we have the encrypted field. So let's see the end. What should we do for the end? Okay, the string encrypted field, which is the one that we want, is initially empty. So we are going to start with an empty string. Pick out 16 bytes of the MD5 hash of the last iteration in this order. So this is the last iteration. Sorry, this one is the last iteration. So they tell us that we need to order them in a different order. So they say first take byte 11. So this is byte 0. This is byte 1. This is byte 2. Okay, 3, 4, 5, 6, 7, 8, 9, 10. 11 will be BF. So you see this BF is because we took byte 11. Then we take byte 4. So this is byte 0, byte 1, byte 2, byte 3, byte 4 is 91. So after BF, we have 91. Blah, 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 blah. So let's do that first. We are going to start with an empty encrypted field, and we are going to reorder the byte of the last iteration. So we have the last iteration in intermediate. So let's do that. So what code do you want to, should we write here to have the new value of intermediate, or to have the new value of encrypted field? How do I get that? How do I get this? So let's call it again intermediate. So I just need to move around the byte. So what instruction should I write? For example, to get byte 11, and to say that, okay, I'm going to start with byte 11, then byte 4, then byte 10. By the way, I can just copy those numbers. So when we write our code, we don't make a mistake because I took them from the PDF file. So I need byte 11. How do I get byte 11 from intermediate?
Intermediate sub for the files.
Yeah, intermediate sub. Okay, if I do intermediate sub 11, Python will give me an integer. If I want it as a byte, I have to say sub 11, 12, which means that I need a sub series of bytes. I will start in 11 inclusive and end in 12 excluded. So let me explain you why I did that. Let me go to Python. Let me define, for example, like R, a series of bytes. So let's put, for example, inside. Okay, I want to put the hexadecimal string, let's say 01, 02, 03, 04, and then 04, 03, 02, 01. How can I do that? I want to define a series of bytes that have that. Do you have any idea how can we write that? So I want 01, 02, 03, 04, then we say again 04, then we say 03, then we say 02, then 01. So if I say R in hexadecimal, which is the nice way to represent it, look at, we have a first byte that is 01, then 02, 03, 04, 04, 03, 02, 01. Let's say that I want this 2 bytes. So I can write R sub. So that will be sub 0, sub 1, sub 2, sub 3, sub 4, sub 5. I start in 5 and go up to 7 exclusive. So 5 inclusive and 7 exclusive. So it will give me the 5 and the 6. Let me show them in hexadecimal. So look at it, give me 0302. You see? Now, if I just want the 03, I can say start in 5 inclusive and end in 6 exclusive. So it just give me 1 byte. Look, if I just put that, give me the 5, it's an integer. You see, it's not a byte, it's an integer. So it's why we need to do that. We need to say, if we want byte 11, byte sub 11, we say we start in 11 inclusive up to 12 excluded. Now, I'm going to concatenate it with what? With intermediate sub 4 inclusive and sub 5 excluded. And I'm going to concatenate it with what? With intermediate sub 10 inclusive and sub 11 excluded. And I'm going to concatenate it with what? So I keep going until I did all the value that they asked me to do, no? So I'm going to concatenate it with intermediate sub 5 inclusive to sub 6 exclusive, and concatenate it with intermediate sub 3 inclusive and sub 4 exclusive, and concatenate it with intermediate sub 9, 10. So I start in 9 inclusive, I end in 10, but I exclude the 10. I'm going to concatenate it with intermediate sub 15, 16, then intermediate sub 2, 3, then intermediate sub 8, 9, then intermediate sub. So it's the same thing several times, no? So here we are going to do 1, 2, intermediate 1, 2, concatenated with intermediate 7, 8. So 7, 8. Concatenated with intermediate 13, 14, concatenated with intermediate 0, 1, concatenated with intermediate 6, 7, and finally concatenated with intermediate 12, 13. So 12, 13. So we have a new value of intermediate, and let's show it. So let me copy this line so I don't have to type it. And let's show the new value of intermediate, and it should be this value that we have here, if we did everything correctly. So let me save the file, and let's run the file again. So this is the new value of intermediate. So let's see. FBF 9113 FE, it seems that's okay. And at the end we have A5 and 9C. So let's look okay. If I want to compare them, can you give me an instruction so I don't have to do it by myself? I want just ask the computer. I give you this string and I want you to compare it with another string. What can I do? So you remember the square bracket operator allow us to compare string, no? So we can use the square bracket operator, compare this string with, let me copy this one. So one from the PDF file, one from my execution. And for example, let's put here equal, if they are equal, different. So it's a equal, of course. Of course, I did not have to do all this. I could just do that and ask, show me the exit status. What should be the exit status if they are equal? Should be 0. When it's walk, the exit status is 0. The exit status is 0. For example, if I change here this C with a D, the exit status will be 1, saying they are different. Okay, so as you can see, they are equal, and I did not have to by myself verify. So we are at this in the third part, which is the final part. We already did that. So now let's see what they say. So they say the string encrypted field is initially empty. Pick out 6 bytes. 6. Oh, we just did that. Okay, now we are here. For each 6-bit group. So look at this big number, this hexadecimal number, we are going to put it in binary. So let's verify, for example, 1011 is B. Then we have 1111, which is F. Then we have 1001, which is 9. Then we have 0001, which is 1. Okay, so it didn't fit in one line, so I put it into lines. So for example, let's verify the last 4. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So this one should be A. Then following is 5, as you can see. Following is 9, as you can see, and following is C. Okay? So they say that this binary number, we are going to divide it in group of 6 bits, starting from the right part. So I take these 6 bits, 1, 2, 3, 4, 5, 6, and I make the first group that is there. Then I take these 6 bits, 1, 2, 3, 4, 5, 6, and I make this group. So I do group of 6, and you will see that here we will have a group of 2. So for this group of 2, what we will do is left pad to convert it to a group of 6. So we will put 40 at the beginning, because this is not a multiple of 6. Okay, because this is 128. 128 is not a multiple of 6. By the way, if I ask, for example, what is 128 modulo 6, it should say 2. Okay, it's why we have a group of 2, and we need to do padding to have a group of 6. So all of them are group of 6. So they say that when we have all of them group of 6, so for example, this value, when you put 0, 0, 0, 0, 1, 0, is 2 in decimal, isn't it? This is a 2. So this 2, you go to the table, the table that we have initially. And we search for a value of 2 to know what is the character. So a value of 2 will be a 0. So the encrypted part starts with a 0. Then we have this value, this group of 6 bit. So this group of 6 bit is 29. Let's verify it. This is 1 plus 4, which is 5, plus 8. 8 plus 5 is 13, plus 16. 16 plus 13 is 29. So this is 29. And if you go to the table, 29 is an R. So let me go one more time to the table. Okay, and we search for 29, it's an R. So for each group of 6, you get the decimal value and you search on the table to get its representation. So what will happen is that the encrypted part will be that. So for example, as we say that no, this is exercise 3. I went too far away. I'm in exercise 3. We are in exercise 2. Okay, so this 2 is a 0. So look at, we have the magic number, then we have the salt, and then what we will have here is this in reverse order. So, or for example, if we take the less, if we start here, we have the Q, then we have the K, then we have the H, then we have the dot, up to the 0. Okay, and this will be the encrypted part. So let's do it. Let's program it. So help me with that. What do you think we can do? So they say start with an empty string. So we start with an empty string. So I need to get this group of 6 bits. How do I get this group of 6 bits? So I have intermediate, no? You remember that we have intermediate. And intermediate have this. So the first thing that we might want to do is to convert intermediate from a series of bytes to an integer. And when it's an integer, we'll do the calculation that we need. So let's convert it to an integer. So let me call it, for example, value. So when I need to convert a string of bytes into an integer, there is a static method in the int class that is called from, I think it's called from value. Let me see, Python 3, let's do help of the class int. Let me search for from bytes. It is called from bytes. So we will give it a series of bytes on the byte order, if it's big endian or little endian. So from bytes, we will give it the series of bytes. The series of bytes is intermediate. On the byte order, this is big endian. So just to make it nice, let's see the value that we have in value. So print, it's an integer, of course, this time, no? So value is, and I'm going to show value, for example, in hexadecimal. How can I show value in hexadecimal? Like that, no? Dot format, and I'm going to show value. So it will be the same that we already have. So look, we are showing a lot of message. For example, here we show every time that we pass in the loop, we show a value. Let me remove that. We don't need to show the value anymore. We are showing a lot of result previously. Let me remove all this. That was just to see our progress. For example, here we show part 1. Let me remove it. We don't need. We show part 1 again. We show alternate. We show part 2. We show part 3. We don't need that. We show intermediate. We don't need that. This is the 4. I already removed it. So when I execute it, it should be much straightforward now. So let's execute it. Okay, so you see, that was a string of bytes, and this is an integer. So we see exactly the same value, but I convert a string of byte into an integer. So my question is, how do I get this last 6 bits of the integer? How do I get the last 6 bits? So how do I get the last bit? If you have an integer that is called value, how do you get the last bit? So I have value. How do I get the last bit of value? We saw that last time. Yeah, value modulus 2. Value modulus 2. Do you understand that this gives me the last bit? If we were in base 10, how do I get the last digit? Modulus 10. Now, if I ask you the digit that is next to the last, let's say that we are in base 10. I want the last digit. Let's do it first in base 10. How do I get the last digit? We say we do modulus 10. Okay. Now I want the digit of the tens, which is the digit that is next to the last. So if I do modulus 100, what will happen? It will give me the last 2 digits, isn't it? For example, let's take the value. Let's say the value is this value. And you do modulus 100. It's going to give you 54. So it's give you the last 2 digits. I want the 5. How do I get the 5? If I want the digit of the 10. So this is the digit of the 1, the digit of the 10, the digit of the 100, the digit of the 1,000, the digit of the 10,000, okay? So I want the digit of the tens. How can I have the digit of the tens? Digit of the ones, which is the last. Now I want the digit of the tens. What about this? Does it work? First, you divide by 10. When you divide a number by 10, what do? You remove the last digit, isn't it? And then when you take modulus 10, you get the last digit. So if I remove the last digit from this number, I remove the 4. And then I do modulus 10, I get the 5. Do you see that? Now, if I ask you, give me the digit of the hundreds. How do I get the digit of the hundreds? Yeah, it will be. So it's divided by 10 2 times, which is divided by 100. Every time that I divide by 10, I remove one digit. So if you want to remove 2 digits, you divide by 100. So this will give me the digit of the 100. So now let's talk about bits. So before we do that, if I want the last 3 digits, how do I get the last 3 digits? You have a number and you want the last 3 digits. Or let's say first the last 2 digits. How do I get the last 2 digits? I do value what? We just saw it, no? Value divided by modulus 100 will give me the last 2 digits. If I want the last 3 digits, what should I do? Modulus 1000 will give me the last 3 digits, isn't it? So let's come back to my question. I have in value this integer, this big integer. I want the last 6 digits. 1, 2, 3, 4, 5, 6. I want the last 6 digits. What can I do to get the last 6 digits? Let's do a while that will show us the group of 6 digits. So let me do a while. While, and I want to show first this group of 6 digits, then this group of 6 digits. So while, what can I write here? While value is not 0, I can write if I want, yeah. What should I do? I'm going to show a group of 6 digits. So group of 6 binary digits. Let's put binaries. Binaries. And I want to show it initially like a decimal value. So what can I do? So we say to get the last binary of a number, the last digit, the last binary digit, we can do modulus 2. What should we do if we want the last 2? Of course, modulus 4 will give me the last 2 because modulus 4 will give me something between 0 and 3. And between 0 and 3, we have 2 digits. If we want the last 3 digits, modulus 8. So if we want the last 6 digits, we will do what? Modulus 64. Okay? Which is 2 to the power of 6. If we want the last digit, 2 to the power of 1. If we want the last 2 digits, 2 to the power of 2. Like in base 10, if we want the last decimal, 10 to the power of 1. If we want the last 2 decimal, 10 square. If we want the last 3 decimal, 10 cube. Okay, so how do I remove the last 6 digits, the last 6 binary? I divide by 64. Okay, let's see this in action. Let me run it. Oh, didn't give me what I am expecting to see. So let's see what is happening. Oh, I know. I'm going to say divided. To be sure, we use the integer division. So divided. Should use the integer division. Let me rerun it to see. Okay. So it say the last 6 binary is 28. Let's see if we have them. 28. Then the other group is 22. Then the other group is 10. Then the other group is 0. Then we have 44. Then we have 37. Up to the last group, which is 2. So let's see the final. We have a group of 36, which is there, that we are going to convert in Y. Then we have a group of 63. Then we have a group of 2. So I show them in decimal, but if you want to see them in binary, what can you write here? I want to show them in binary. I can just say, okay, show them in binary. So I'm going to use dot format. Dot format is very powerful, no? Because you can format as you want. And here I'm going to place a placeholder. If I just let a placeholder like that, it will be in decimal. So I'm going to put 06 binary. You understand what 06 binary mean? Show me of a 6th position the number in binary. And if the number is small and need less than 6 binary digits, I'm going to left pad. So let me rerun that and look at what we have. So for example, let's compare it now with this. You see this group of 6-bit is this group that we have here. And here I put it on the line. Then you see the second group that we have here is the one that will come here, 3, 4, 5, 6. Of course, here I'm going to get lost because this is binary. I better go here. So the third group, this one, is this one. The fourth group, this one, is this one. On the last group, for example, this is the 2. Remember, I told you we are going to do padding because the last group have only 2 bits. You see, the last group here have only 2 bits. We need to do left padding to bring it to 6 bits. So we can treat it like the other group of 6 bits. But as you can see here, we have all the groups. So now that we have done that, we just need to implement what? A conversion that will take a group of 6 bits and will bring me to a symbol. So for example, if we have this group of 6 bits, which is 2, I need a 0. Okay? If we have this group of 6 bits, which is 0, I need a dot. So we need to convert from a value that is between 0 and 63 to a character. And this character can be a dot, a slash, a digit, a capital letter, or a lowercase letter. So help me with that. How do I implement this table? So let me remove that. That was a message to help me. We don't need it anymore. Let me remove that. That was a message to help me. We don't need it. That was just debugging message to be sure that I'm doing right. we already know that we are doing right because we show the value here and the value is correct. So how do we get the encrypted field? Okay, we have this table. Let me, yeah. So we have a field that is called encrypted field, and it starts as an empty string. Oh, it was written here already. I wrote it again. Let me remove it. Okay, so before the while. So here what we need to do, instead of showing the field, we need to add something to, we need to append something to encrypted field. So what should I do here? How do I update encrypted field? So let me put group of 6 bits. How do I get a group of 6 bits all the time? I do value modulus 64. We already say that. Now that I have a group of 6 bits, if the group of 6 bits is 0, I need to append a dot. If it's a 1, I need to append a slash. If it's a 2, I need to append a 0. If it's a 3, I need to append a 1. So what can I write here to do that? Give me some code that will do that for us. Well, the truth is that group of 6 bits is an integer. The way that you interpret this integer is your way. Remember, this integer is in memory. If you are going to display it, you can display it as a decimal number, as a binary number. We display that both. We display at one point as a decimal number, then I display it as a group of 6 bits. This is just a display, but we have the value. So I need to say if the group of 6 bits is 0, I need to append a dot. If the group of 6 bits is 1, I need to append a slash. If the group of 6 bits is a 2, I need to append a 0. So what can we write here? Hmm? The value, we put in the value in the table? We could do a table, you are right. So we can do a table where we put all this value. That will work perfectly. So you are totally right. So I might do that, no? It will take me some time to do the table. So let's do it with a table as you propose. So let me define here a table. Table. And we are going to put all the value that we need. So first, we need a dot, which will be the sub 0. Then we need a slash, which will be the sub 1. Then we need a 0. Then we need a 1. Then we need a 2. Then we need a 3. So it's going to take me some time to do the table, but I can do it. You understand? We can use this table.
I was saying, like if it's ASCII table, since it's better to start saving is less than table that's fine. Sorry, defined.
Yeah, I know what is the we have the table, yes.
Than less than, or you just add a to value at the ASCII.
Okay, we can do something like that. So That's fine, what you are saying. So let's do it in the if. We have an if here. So group of 6 bits, it might be long. Let's just use 6 bits. So we can say, if the 6 bits is equal to 0, what should I do? I need to append a dot. So I'm going to say append a dot. Otherwise, if the 6 bits is equal to 1, I need to append a slash. Otherwise, if the 6 bit is a digit, so how do I know that it's a digit? So if the value is between 2 inclusive and, let's see, 11. You see, 2 from 2 to 11, we have digits. So if it's from 2 to 11, what are we going to do? We are going to append what? CHR of what? Of 6 bits. How do I convert that to the ASCII code? For example, 0 is 2. And the ASCII code of 2 is what? 48. So what should I do here? Good, add 46. Thank you so much. You are right. I need to add 46. Now we have another else. Let's do the uppercase letter. So the uppercase letter start in 12 and go up to 12 and go up to 37. So if it is between 12 and 37, what should I do? So capital A is 12 here, but the ASCII code of capital A is 65. So I should do what? I need to add what? So capital A here is, where is capital? Is 12. And the ASCII code should be 65. So what do you add to 12 for it to become 65? 53. 53 plus 12 gives you 65. So you are going to add 53, isn't it? So if it's a capital letter, otherwise it will be a lowercase letter. So I don't need to check it. If it's a lowercase letter, what should I do? So the A is 38. And the ASCII code of A is 97. So what should I add to 38 to get 97? In other words, what is 97 minus 38? 59. I need to add 59. So I'm going to add 59. Okay, so look, we are going to do that and show the value of encrypted field to see if it's worked. So after doing all the Y, we come here and we show the value of encrypted field. So encrypted field is equal to, and we are going to show encrypted field. So it's not totally correct because we did a while. Instead of a while, I should have done a for. I need to pass 22 times. For I in range, because there will be always 22 groups. Okay, let's see why I say that. 22 times 6 plus 2 will be 1. So there is no 22 groups. So it's 20 group. $128. 128 divided by 6. 21 group. So it's 21. No, don't know why I have the impression it was. Oh, 21 plus 1 is 22. Yeah, I'm right. It will be 21 plus the one that we will extend from 2 bit to 6 bits. It will be 22. So we'll do that 22 times. Okay, let's run that to see if we get the correct result. So look at the field that we have get. So let's compare it with what they say and see if we have the same result. So this is exercise 2. Here we are. And they have, after the dollar, we have the encrypted field. QK8.GZ, and it ends with DFYZ0. So as you can see, we did it correctly. So now that we know that we did it correctly, we are going to show what we need to show. So the hashed password, hashed password is, and we are going to show what we need to show. So it has to start with $1. Then we will have the salt, and then we will have the encrypted field. So now let me run the program a last time, and we should have the correct result. So look at, this is the encrypted password, is Eric encrypted with this hash. This program, we made it ourselves, as you can see in Python. Now, you remember that I installed a program that is called make password. We are going to ask make password to compute it also to see if make password find the same thing. So I'm going to say the method that I use is MD5. The password that I want to encrypt is Eric, and the salt that I want to use is this salt. So look at this result, and our result should be exactly the same. This was computed by a tool that we installed last time, and this is computed by our program. As you can see, it's the same. So look, to verify even a little more our program, I'm going to say compute another hashed value for Eric. How do I verify that this is correct with our program? So what the make password command just did is what? It computed a hashed value for Eric with another salt. You remember that we have a lot of salt. So now with our program, how do we verify that? So we take the salt that is there. See the salt between the dollar and the dollar? We copy it and we give it to our program. So we say, encrypt Eric with this salt. And look at this is exactly what the make password command find. But the make password command, when we don't specify the salt, for example, here I'm going to do it another time, it's take a random salt. So of course, this salt is not as the previous one. So if I want to verify with our program, I say, okay, use this salt. With this salt, there is only one representation of Eric. And this one that is there is the one that make password just fine. So you see, we did a program that is able to compute the hashed password of a user. So let me show you. We are going to create a user in this machine. Who know how to create a user? We can use add user. This is an interactive command. So let me switch as an administrative user, because to add a user, I have to be root. So the password that I type here is the password of Eric, which is internet 2. Now, if I check, I am an administrative user. So I can use add user as mentioned by one of you. So let's say that we are going to create a user that is called John McDonald, for example. So this is the login, and then it will guide me. So I say, okay, I'm adding a user, that will be the user ID. I create a new group, that will be the group ID. So it's saying, tell me, give me the password of John. Let's put John Pass. Oh no, let's put Eric. No, let's put John Pass. Yeah, let's put John Pass for now. John Pass. And retype John Pass. So I say, what is the full name of John? John McDonald. What is the room number? I'm not going to specify the phone number, the home number, other information. Is this information correct? Yes. So we have a new user. So, thing that I've not tell you that the information of the user in Unix is stored in two files. Do you know what files are used to store the information of a user? Two files are key to store the information of a user. What is the name of the first file? So the first file is called /etc/password. So I'm going to see the content of this file. And we'll have one line per user. And this is a comma separated file where the separation is done not with a comma, not with a tabulation, but is done with colon. So the fields are separated by colon. So look at the file. Let me open a little more so we see the file better. So look at, there is a line for the user Eric. And here is the line for the last user that I just created. So let's see. We have several fields, as I told you, and they are separated by column. So the first field is what? What do you think that this is? The first field is what? The logging. You remember when we type add user? I put add user space John. So this is the logging. If this person secure shell, this person have to secure shell like John. Then we have a second field, which have an X. Do you know what is this X? So in the past, some years ago, it used to be the hashed password. Then for a reason of security, they move it to another file, which is the second key file. So this is the place of the hashed password in the past. When we have an X here, it means that the hashed password is not there, but in the other file. So we will find the hashed password in the other file. Then what is that? The user ID. So each user is represented by an integer. And when you start creating user, the first user have an ID of 1000. So the first user, non-administrative user of this machine was Eric. And look at, he have an ID of 1000. We create a new user. You have an ID of 1001, 1002, 1003 if I create more users. Then we have the primary group ID. A user belongs to a group. So look, if I type ID of John, it says that John have this user ID, and John belongs to this primary group ID 1001. So this is the primary group of John. Then this information is called the GCOS information. It's where you put the first name and the last name, an additional field if you want. Then we have the home directory of the user. And then we have the bash, the default shell that the user will use when he logs into the machine, which is bash. So if you look Eric is similar. We have a logging. We have X saying that the password is not there. The hashed password is not there. Then we have the user ID, the primary group ID, the GCOS information of the user, the home directory of the user, and the default shell that the user is using. Let me create a new user, but this time I'm going to use another command. There is another command that is called user add. It's a more basic command, but when you do scripting, it's not interactive. The other one is interactive. It's force me. I cannot use it if I do a script. This one I can use it. So look at this option. -N is create a home directory. -S is the user is using this shell. Is using the bash shell. -C is the GCOS information. So let's create, for example, Mitchell Johnson. Mitchell Johnson, and then the username. Let's put M for Mitchell and Johnson. So M Johnson, I'm going to create. So it's not going to ask me anything. You see? The other is interactive. Now, if I go inside this file, look at, after the line of John, that was the last user that we create, we have a new user, M Johnson, which is the logging. The password is not there, it's in the other file. This is the user ID of Michelle Johnson. This is the primary group ID of Michelle Johnson. This is the GCOS information of Michelle Johnson. This is the home directory of this person. And this is the shell that this person is going to use by default. So I create a user. If I want to specify the password of Michelle Johnson, because I didn't specify it, I could have put it in the command line. I can do, for example, password M Johnson. Let's put as password M Johnson to keep it easy. Johnson M Johnson. Okay, I mistype it. M Johnson. M Johnson. Okay, it was updated. So there is another file. This is the first file of the user. The other file is a file that is called shadow. Which is this file. So each user will have one line. So let's see the line of Eric. This is the line of Eric. So look, we have the logging. Then we have the encrypted password, the hashed password. So look, we have the magic number, which is not $1, which means that we didn't use MD5. Then we have the salt. It's bigger, as you can see. Then we have the encrypted field is much bigger because the $6 hash method use SHA 512. So it's MD5 have 128 bits. SHA-512 have 512 bits. So it's why it's much bigger. Look at, for example, John. We have the logging separated by the hashed password, separated by other fields that we will see after. So by default, we are not using in this moment SHA. We are not using MD5 anymore. We use MD5 maybe 10 years ago. But we found some weaknesses in MD5, so we are not using MD5 anymore. We are using another algorithm, which is SHA-512. So let me force the system to use MD5. So there is a file that is called etc pam.d, sorry. And here the file is called common password. Common password. And in this file, there is a line, which is this line. You see, password. Here I'm saying I want to use SHA-512. So I'm going to say no. From now on, I want to use MD5. Let's go back 10 years ago. So let's change the password, for example, of Eric. No, let's change the password, not Eric, because I'm going to use the Eric after. Let's change the password of John. You remember the password of John? In this moment, let me show you again the password of John. So grep John in the file shadow. So look at the password of John. Oh, there it shows me also Johnson because there is a John in Johnson. Okay. So if I have just one John, let me say just one John. I just want John. Okay, this is just the line of John. Look at the password. It uses SHA-512. Now we are going to change the password of John. So I'm going to say password, change the password of John. What password do you want to put it? Let's put Jacksonville, for example. Jacksonville. Retype Jacksonville. Okay, it was updated. Let me show you the password now. Look at the password. It's not the same one. And this time it used MD5. Why I know that it used MD5? Because the magic number say it used MD5. Here it was saying it used SHA-512. So we are using MD5. How can I verify now that this is Jacksonville? How can I verify that this password is Jacksonville? With our program. We did a program, so we can verify with our program. We can ask our program, please encrypt Jacksonville. I want to see the hashed version of Jacksonville, and it should be this one. So help me with that. What should I type with our program to verify that if I encrypt Jacksonville, it will give me this string? Yeah, so Jacksonville, I want to encrypt Jacksonville. And what is the salt? So look, it chooses this salt. So I just copy this salt and passed it here. Remember, the salt is a random salt. Look at, this is the way that you encrypt Jacksonville. So compare it. This is the encrypted part, the encrypted field. F6QBW. If I go after the dollar here, where is the dollar? Oh, I forgot in the program, I forgot to show another dollar. So let's add that. Here we forgot to, we show $1, the salt, then $1 to separate it, and then the encrypted field. So let me do it again. So small, I put I forgot the concatenation here. Okay, let me do it again. So look at, after the $, we have the encrypted field. So both should be exactly the same. So verify F6QB, F6QB, and it's end with /CG dot, and it's end with /CG dot. Now, let's say that the user, Johnson, Mitchell Johnson, also to Jacksonville. So let me put as password Jacksonville. 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 Let's see the password of the two users, the Michelle Johnson and John, both users. So grep the John in the etc shadow file. So look, this is Jacksonville, and this is also Jacksonville. So we already verified the first Jacksonville. Let's verify that also M. Johnson of Jacksonville. So what can I do here? What can I do to verify it? So I'm going to do encrypt Jacksonville with this new salt. And it will give me another hash. And this hash is different from the previous one. Look, for example, it start here, TFQE, TFQE, and it ends with KCY1, it ends with KCY1, as you can see. So you can see the two users have the same password, but by looking at the hashed version, I cannot guess that they have the same password because it is different. So as you can see, we don't store your password in clear text. So what will happen if I secure shell to this machine? How do the system verify my identity? Because there is no way if I give you this that you can return to Jacksonville. So this function is only one way. You can go from Jacksonville to this, but you cannot come back from this to Jacksonville. This is called a hash. A hash is always one way. So it's easy to go from the string to the hash version, but it's very computational intensive to try to go from the hash version to the original. So there is no way for me to go from this to Jacksonville. So how the system can authenticate you? How do you think that the system do? Thank you. Of course, when you type your password at Jacksonville, it's compute the hash of your password. Then it compare the hash that it just compute with the hash that is stored in the file. If the two hashes are the same, you are granted access because you know the password. But even the administrator cannot guess your password because it is hashed. Unless you are an innocent user and you use an easy password. You should never do that. Never use password, for example, that correspond to a word of the dictionary. For example, Jacksonville. Never use that because they will guess your password. Never use password with very few characters. Less than 8? No. Too short, because up to 7 characters, we have enough power to make a brute force attack on your password and to guess your password in a few hours. You don't want that. So in the class of Tuesday, we are going to see a cracking tool that will do this work for us and will crack easy password. Like for example, Jacksonville, it will crack it. If you put any word that is in the dictionary, the hacking tools will find your password. So they don't recommend to do that. So what they recommend, for example, you can memorize a password. Let's say that I want to have a password. So I can say, I went to New York in 2022 and had a good time. So you can generate a password with that. You take, for example, the first letter, I, W, T, and Y. I went to New York in. So then you have I. You put 2022, for example, and add a good time. The only thing that we don't have any special character, but you see, as easy to remember this password. So you have lowercase letter, uppercase letter, digit. You still miss some punctuation, some special character. So you can add special character. So for example, you decide to end it with a plus. That will be a very strong password, and you don't have any problem to memorize it. So this is a recommended way to generate a password that looks random, but is not random at all. Okay, because it's something that is related to you, because you went to New York in 2022, so you will remember it. Okay. Okay, let's end the class for today here, and we see John the Ripper in the next class.